13.3, we're going to look at finding probabilities using combinations. We've already done it with permutations. We're now going to do it with combinations. And if you remember our example in the first section, the letters A, B, C, what are all the different permutations? And permutations mean order does matter, order matters. I take A and then I'm left with the options B, C or C, B. I pick B, I'm left with AC or CA. And I pick C, I'm left with BA or AB. So I can see that I have 6 permutations. And that order matters. What if I take those same three letters? Actually, let me, before I do that, give you the equation that we did in the last chapter, which is the permutations of n objects, in this case 3 objects, taken r at a time, taken 3 at a time here, is n factorial over n minus r factorial. And if I were to substitute 3 and 3, 3 factorial is 3 times 2, which is 6. So I get 6 in the numerator. And since I have 3 objects taken 3 at a time, 3 minus 3 is 0 factorial is 1 in the denominator. So 6 in the numerator divided by 1 in the denominator. Here are my 6 permutations. Okay, let me look at combinations of these same. What are the combinations of A, B, C? Well, there's one, A, B, C. It doesn't matter if CBA, ABC, BCA. You have one single combination because order does not matter, right? Does not matter. So the equation for combinations, and this is new, make sure you write it down, is n objects, again 3 objects taken r at a time, again taken 3 at a time, is n factorial n minus r factorial, exactly the same as the previous equation, with one little difference. You're multiplying this in the denominator by r factorial. That's the only difference. So what happens? Well, my number on top is the same because I still have 3 letters, so 3 factorial, right? But on the bottom, I get 3 minus 3 factorial, I get 0 factorial, right? Times 3 factorial. Well, 3 factorial on top and 3 factorial on the bottom is going to give me 1. Okay, let's look at example 1, and we'll see it work in that example again. Example 1 is also using letters. You have the letters A, B, C, and D. And we're going to look at all the permutations of 2 of the letters. Okay? What are all the permutations of 2 of the letters? Well, we'll just start. We'll start with, if I pick A, I can have B, or I can have C, or I can have D. And if I pick B, I can have A, BA, BC, BD. If I pick C, I can have CA, CB, CD. And if I pick D, DA, DB, and DC. Okay, so I can see that I have 12 permutations, because if order matters, I have 12 permutations. But if I cross out any duplicates, because in combinations, right, it doesn't matter. So if I have the same combinations of letters, but they're in a different order, I have to cross it out. So AB and BA, there's one combination between the 2 of them. if I have CA and AC, there's one between them. CB, BC, one between those, AD, DA, and CD, DC. So I have 12 permutations, but I have, what's left? 1, 2, 3, 4, 5. Whoops, I have a duplicate. Let's see. It should be only 6. 1, 2. Do I have a duplicate? Let's see. Oh, there we go. BD and DB. There we go. I've missed one. 1, 2, 3, 4, 5, 6. 6 combinations. Okay, now if I've done this right, my equations will reflect it and show why. So if I'm doing my permutation equation, I should end up with 12, and let's see what happens. Permutations of n r equals n factorial over n minus r factorial. So my permutations are going to be, let me move it up slightly so I can see. I have, so this is for, actually let me just put in my numbers. I have 4 objects, and I'm taking 2 at a time. So I have 4 factorial over 4 minus 2 factorial. So my permutations are going to be 4 times 3 times 2 times 1 over 2 times 1. And so as I can cross out my 2 and my 1s, I can see that I have 12 permutations, right? Just as I said up here, I have 12 permutations, okay? And that's a match. Let's look at my combinations and see if the combinations equation is going to work. So I have a combinations of n, r, which is n factorial over n minus r factorial times that additional r factorial, okay? What does that look like? It looks like a combination of 4 objects taken 2 at a time, and I have 4 factorial divided by, same as above, 4 minus 2 factorial, but I also have to add that r factorial, the 2 factorial. So what's that going to give me? 4 times 3 times 2 times 1 divided by, this is 2 factorial, so 2 times 1 times 2 times 1. Well, I know that 2 times 2 is 4, so I can cancel that. So I get left with 3 times 2 is 6. And 6 is the number of combinations that I found when I did it by hand, okay? So that is how you will find combinations. And now that we've done the mechanics, we're going to turn to a couple of examples to do it in practice, and that will finish 13.3.